We're counting down the 10 most expensive steam locomotives ever to thunder down the rails. These aren't just marvels of engineering. Each one demanded a fortune, not only to build, but to keep the very world beneath them from collapsing. From modern legends that drained national museums and corporate giants to historic titans so massive they cracked bridges, every entry on this list set new records for cost, ambition, and unintended consequences. Some blew budgets before ever turning a wheel. Others forced entire railroads to reinforce tracks, rewrite safety rules, or face public outrage. Why did railroads keep pushing the limits, no matter the price, no matter the risk? Let's start our journey with number 10. The Flying Scotsman is more than a symbol of British rail. It is a lesson in just how expensive it is to keep steam alive in the modern world. In 2004, the National Railway Museum took on the overhaul of this legend, expecting a routine restoration. Instead, the project turned into a 12-year odyssey of rising costs, technical setbacks, and public scrutiny. The final bill landed at £4.2 million, the largest sum ever spent on a British steam locomotive overhaul. Certification with the Office of Rail and Road alone cost hundreds of thousands of pounds, as every bolt and boilerplate had to meet 21st century safety standards. Delays stacked up, and so did the invoices. Specialist contractors, new axles, modern braking systems, and a 3-year wait for final approval all added to the total. Letters from donors and parliamentary transcripts filled with frustration and questions about accountability. Yet, despite the headlines and the heated debates, the Flying Scotsman rolled out again. Proof that even today the true cost of steam is not just measured in steel and labor, but in the millions needed to keep history running on time. Union Pacific's decision to bring Big Boy 4014 back to life wasn't a restoration. It was a resurrection on a corporate scale. The locomotive itself weighed £1.2 million, but the real weight was in the numbers behind the scenes. More than $7 million flowed into the project, with the final tally climbing higher as invoices stacked up. Over 122,000 hours of skilled labor were logged, every weld and bolt documented for federal records. Modern safety rules from the Federal Railroad Administration demanded new boiler certifications, ultrasonic testing, and custom fabricated parts that had not existed for decades. Each permit and inspection came with its own fee, adding hundreds of thousands more to the ledger. Shop diaries from Cheyenne read like a marathon. Crews worked around the clock, pushing through setbacks and waiting for the next round of approvals. The paperwork alone filled cabinets. For Union Pacific, this was more than nostalgia. It was a multi-million-dollar bet that history could run under 21st century rules. The result was a living giant, and it proved the true cost of steam now lies in the hands of regulators, engineers, and accountants. When the first rivets went into Tornado's frame, Britain saw something it had not seen in almost 50 years, a mainline steam locomotive built entirely from scratch. This was not a museum rescue, and it was not a government project. The A1 Steam Locomotive Trust, a volunteer-driven group with no public funding, set out to rebuild a lost class of engine using donations, bake sales, and sheer determination. Dreams ran headlong into the realities of the 21st century. Modern steel had to pass tests no Victorian engineer could imagine. Every weld and casting faced scrutiny from the Office of Rail and Road. Certification came with rounds of materials analysis, boiler pressure tests, and reams of paperwork. Each new requirement brought another invoice, another fundraising appeal. By the time Tornado steamed out in 2008, the final cost had soared past £3 million. At 105 tons, Tornado was more than a tribute. It was a warning about the price of ambition in an age of regulation. The lessons learned here would soon be tested on an even bigger scale. The P2 Prince of Wales is a steam locomotive built for a century that no longer exists. Its price tag is very real, and it is not finished yet. Budget projections for the Prince of Wales now stand at over £6 million, making it the most expensive new-build steam locomotive in history. That number is more than double Tornado's final cost. Every component must meet modern certification. The Office of Rail and Road demands rigorous testing for materials, welding, and assembly. The paperwork alone fills binders. Each round of approval means more time and more money. Supply chain delays have pushed deadlines back, adding hundreds of thousands of pounds to the bill. Certification and paperwork are a steady tax on the project. The P2's axle load, over 22 tons, forces special attention for track and bridges. Contractors submit estimates, and each estimate brings another surprise. Internal meeting notes from the P2 company capture a mood swinging between optimism and anxiety as the fundraising gap widens and the engineering challenges multiply. Axle load and infrastructure are where the costs keep growing. The Prince of Wales is not just a locomotive, it is a test of how far ambition can go in an era of relentless scrutiny and rising costs. With every invoice, it becomes clear, in the 21st century, the true weight of steam is measured in millions. Union Pacific's Challenger. Challenger wasn't just another big engine. It was a 612,000-pound warning, a sign that the ground itself had limits. Delivered during the height of World War II, each Challenger carried a builder's invoice for $261,000, an astronomical sum for the early 1940s. But the real price came after the engines arrived. In April 1943, Union Pacific dispatchers sent out a bulletin. Bridge crossings west of Cheyenne were capped at 25 miles per hour until the girders could be reinforced. Crews reported that the rails vibrated so violently they could feel the tremors under their boots long after the train had passed. Maintenance logs from the same year detail complaints of wheel slip, and bridge crews were called out in the middle of the night to check for stress cracks. The railroad scrambled to pour concrete, add steel, and shore up dozens of spans, sometimes at a cost that rivaled the locomotive's own price tag. Every mile the Challenger ran, it forced the system to adapt, pushing the limits of what American railroads could bear. The Challenger's legacy was more than power, it was a lesson. When you build for speed and strength, the entire network pays the bill. Norfolk & Western's Y6B was born at the very peak of steam engineering, an engine designed to move mountains of coal across the Appalachians, no matter the grade or the weather. Each Y6B cost $247,000 to build in 1948, a staggering figure for the time, and weighed in at 170 tons just for the engine itself. But what really set the Y6B apart was the raw power. With a compound articulated design, these locomotives produced over 5,000 horsepower, more than enough to pull the heaviest trains on the line. Shop logs from Roanoke detail a relentless cycle of overhauls, with heavy service intervals needed to keep all that machinery running at full tilt. The Y6B's complexity meant more time in the shop, more skilled labor, and a never-ending list of parts to replace. Every hour spent on the main line was matched by hours under the wrench. Maintenance crews grew familiar with the rhythm, rods, valves, and bearings wearing down under the strain of late-era freight demands. Invoices for locomotive Y6B17 showed just how quickly costs piled up. Even as diesels began to take over, the Y6B fought to prove that steam could still compete, but at a cost that kept climbing. The engine delivered everything the railroad asked for, except relief from the burden of upkeep. In the end, the Y6B stood as both a triumph of engineering and a warning. When you push steam to its limits, the bills never stop coming. On paper, the Pennsylvania Railroad Q2 duplex looked like the future. Built in 1944 with a price tag of $462,000, it was one of the most expensive steam locomotives of its era. The Q2's 67,000-pound axle load and experimental duplex drive promised unmatched power for heavy freight. But the real story unfolded in the offices and workshops, not just on the rails. Internal ledgers from the Pennsylvania Railroad show that, over its service life, the cumulative cost of maintenance, modifications, and compliance paperwork soared past the original build price. Mechanical department memos from 1948 describe inspection forms piling up. One memo even joked that the stack of mandatory paperwork exceeds the smokestack. Every mile required shop time, special parts, and extra technician hours. The Q2's complex valve gear and constant mechanical tweaks meant more downtime and higher repair bills. By 1950, cost per mile reports revealed that just keeping a Q2 running often cost more than running an entire diesel consist. The Pennsylvania Railroad's own cost reports recommended early retirement, citing the impractical expense of ongoing certification and inspection compliance. In the end, the Q2 wasn't just a marvel of engineering, it was a warning that the hidden costs of ambition could bury even the biggest dreams under mountains of forms and invoices. The Chesapeake and Ohio H8 Allegheny was built to conquer the mountains, and the price was paid in steel, sweat, and shattered nerves. Each engine cost $232,000 in 1941, but the real expense began the moment they touched the rails. With an axle load of 90,000 pounds, the Allegheny pressed down harder than any locomotive before it. On its first test runs, Chesapeake and Ohio's bridge crews listened for sounds they had never heard: the low groan of girders under strain, metal flexing where it should not. Inspection logs from April 1941 record stress cracks in the New River Bridge after a single passage. Maintenance teams were called out before dawn, patching steel and tightening bolts just to keep the line open. The ground shook as the Allegheny thundered by, sending vibrations through the track and into the bones of anyone nearby. Track inspectors reported rails bending under the weight, spikes working themselves loose, and ballast shifting after every run. Emergency repair invoices soon rivaled the cost of the locomotives themselves, with entire spans reinforced in a scramble to avoid disaster. Internal memos described the situation as a race between the engine's power and the limits of Chesapeake and Ohio's bridges, one that the railroad could barely afford to keep up with. Every mile demanded more than coal and water. It demanded new steel, overtime hours, and a constant state of alert. The Allegheny did not just move freight, it forced the entire system to evolve or break. For the first time, the real cost of steam was written not just in ledgers, but in the scars left on the landscape itself. Union Pacific's Big Boy wasn't just a locomotive, it was a challenge thrown at the entire American West. At one point, 2 million pounds, with an axle load of 67,000 pounds, the Big Boy demanded more from the ground than any engine before it. The builder's invoice for each engine read $265,000 in 1941, but that was only the beginning. Before a single Big Boy could cross Wyoming, Union Pacific's engineering office issued a flurry of bulletins. Bridges would need new steel, rails would be replaced with heavier sections, and even the ballast beneath the tracks had to be rebuilt. Internal analyses compared the total investment to the cost of a squadron of fighter planes. In the years between 1940 and 1944, more than $2 million flowed into reinforcing the main line from Ogden to Green River. Timber trestles vanished, replaced by concrete and steel. The rails themselves grew thicker, jumping from 112 to 136 pounds per yard. Engine houses and turntables were torn out and rebuilt just to fit the new giants. For every mile Big Boy gained, the railroad spent thousands of dollars shoring up the world beneath its wheels. Inspection reports from the first test runs tell the story in plain numbers. Bridge deflection was measured in fractions of an inch, track spikes worked loose, and maintenance crews were called out to re-nail entire stretches of track. Union Pacific's own press releases called it a century of progress, but the cost was clear in every ledger. The Big Boy forced the railroad to remake itself, proving that sometimes the price of power is paid not just in steel or coal, but in the very bones of the land. And yet, even this was not the final word in steam's arms race. One engine would go further and cost more than any before it. The Pennsylvania Railroad S1 was a locomotive built to outshine every rival and every record. On the invoice from Baldwin Locomotive Works dated late 1939, the number is clear: $669,780. In today's money, that is over $13 million spent on a single machine, a sum that dwarfed the cost of any other steam engine before or since. Stretching 140 feet from coupler to coupler, the S1 was the longest passenger locomotive ever built. Its axle load reached 64,000 pounds, a weight so great that only a handful of specially reinforced tracks could bear it. PRR board minutes from November 1939 capture the mood. President Martin W. Clement called it our nation's locomotive, a wager on American supremacy in steel and speed. Designer Raymond Loewy demanded nothing less than a streamlined icon. Mechanical engineer Axel Vogt pushed for radical innovation no matter the price, but the S1's ambition came with consequences. The locomotive was too large for most of the PRR's own network. It spent much of its life confined to exhibition tracks, first at the New York World's Fair, then running a limited schedule between Chicago and Crestline. Each trip required careful planning and special crews. Bridges and turntables had to be checked, reinforced, or avoided entirely. Internal correspondence reveals directors warning that the S1 was a monument to ambition more than operational need. Mechanical logs tell of persistent wheel slip and chronic shop time. Maintenance costs soared as technicians wrestled with its unique design. Facility records show one-off upgrades, oversized pits, extended turntables built for the S1 alone. In just over 5 years of service, the locomotive's total cost, including upkeep and infrastructure, ballooned far beyond its original invoice. The S1 was a marvel, but it proved that there are limits even to progress. In the end, it stood as the ultimate lesson. Sometimes the world simply is not ready for the machines it dreams up. Across all 10 steam giants, one truth stands out. The true price of power is what the world must sacrifice to support it. Each locomotive pushed not just steel, but the limits of land, money, and imagination. That pattern endures. Today's technology still tests the ground beneath our ambitions. In rail, as in progress, the real cost is never just the engine. Thanks for watching. What shocked you most?